Hi, everyone. I'm Sonia, and I love science. The reason I love science is not because I'm some genius physicist or super fast at solving math problems or really savvy in the lab. I just kind of look around and I wonder about things and I ask questions and I let my curiosity lead me down a learning pathway. So that is why I'm here with you today. On behalf of CK-12, let's do some science. Let's ask some fun questions and travel down a learning pathway together. Alone, but together. So to start us out, let's grab a common household object, a flashlight. Let me see that you can see this. Okay, flashlight. Probably most of you have one of these at your house, or at least you've seen or used one before. If so, then you have used a simple circuit. Sounds pretty cool and fancy and sciencey, right? So let's just start with the parts of the flashlight. So here I have the switch, turns it on and off. Don't want to scare you there. And I have the light bulb. And then if I get really curious, I might want to open up my flashlight and see that I have two batteries. And they line up just like this. And these are D batteries. So maybe you have a flashlight at home. You can go grab it, open it up. What kind of batteries are in your flashlight? AA, AAA, C, lots of choices. Okay, so the cool thing is CK-12 has a simulation called Flashlight, and it shows all the invisible things that are happening inside this simple circuit so that we can learn more about electricity. So I'm going to share my screen with you now, and I'm going to hop on the CK-12 website. Okay, so hopefully you guys can see my screen. And here is the CK-12 website at, that's right, it's on my shirt, www.ck12.org. I'm just going to scroll down. Lots to do here, lots of fun. And here's some simulations. So I'm going to click on the simulations page. And that's just what I was saying. They have a flashlight sim. How cool is that? So I'm going to click on it. All right. So as I said, the main thing about being a scientist that makes a scientist is just asking good questions. So here is our big question of the day. How does electricity flow in a simple circuit? So when I say the word electricity, I want you to shout out the first thing that comes to mind. Ready? Electricity. Ooh, those are all really good things to think about. Really good. So now maybe you'll think of a flashlight, right? All electricity really means is the movement of charge or the movement of electrons, okay? So electrons moving, that's what electricity is. And when you have a circuit, electrons move in a circle. So that's what the word circuit means. So I'm going to go into what we at CK-12 call the sandbox, the simulation sandbox. And that's because it's meant for you to jump in and play around and explore and discover new things, just as like a kid does in a sandbox. Now I'm gonna hide the graphs. We'll get to those later. And the cool thing you can see is this looks exactly like my flashlight at home, right? So I am going to adjust here. This is called a slider, and it allows me to adjust the battery voltage. Now I had D batteries in my flashlight, and D batteries are about 1.5 volts. So I'm gonna scroll down to 1.5 volts. So now this is literally exactly the same model as my flashlight at home. Now I said maybe you open up your flashlight if you have AA batteries or AAA batteries. I encourage you to go figure out how many volts are in those batteries and then adjust this slider so that it models your flashlight at home. So right now I have two D batteries at 1.5 volts lined up here using this voltage slider. Now also I have the resistance slider, and the resistance really controls my light bulb. In this model of a flashlight, the light bulb is the resistor. Now, the only reason it has kind of this name, resistor, is that it is going to resist the flow of electrons or that current, okay? So let me show you what that looks like. When I turn the switch on, just like I did at home, I turn the switch on, you see, whoa, these little green dots start flowing and my flashlight turns on. So the little green dots must be the electrons, and they're moving in a circle in my circuit. Now I have this really cool microscopic view here, because like I said, the whole fun thing about the simulation is it's making the invisible things happening in my flashlight right here, right? This is literally going on right here. The electrons are flowing through, and you could see here, those red dots are the atoms in the light bulb. So the electrons are flowing through, and you can see they're colliding and hitting the atoms of the light bulb. That's why the light bulb is called a resistor. It's almost like a football game, right? With the offensive line being the resistance, or a rugby game. They're colliding and they're kind of trying to block that flow of current. And you can see that the resistance is measured in ohms. So I would like you to say it with me now. Ohm. Resistance is measured in ohms. Now, the resistor in this circuit is the light bulb, but a resistor can be anything that blocks that flow of current. So it could be a fan, it could be a TV, a refrigerator, anything that you kind of put into the circuit that blocks the flow of charge, okay? And the last slider that I have here gives me an option to see a realistic view of the flashlight model or an ideal view. Now, all this means is this, that when we have these collisions, the atoms jiggle, producing light, but also they produce heat. And in a realistic model, we'll take into account and try to measure the energy that's released as heat. But in an ideal model, we'll kind of ignore that because it makes the numbers just not as pretty. We'll get back to that later. Okay, so hopefully you're comfortable with our sliders, you're comfortable with what you're looking at here, and let's learn some science, right? That's why we're all here together. So the first big idea, and I'm calling it a big idea because it's going to make your brain bigger, right? Not really, but kind of. The first big idea here is electric circuits are all about energy. And I know you've been home for a long time. You guys have lots of energy. It's all about energy. So we're going to focus on energy today. So basically, a simple circuit is all about energy and the transfer of energy. So the battery provides the energy in this simple circuit, and it's ultimately transferred to heat and light. Now, how does this happen, you ask? Which is a great question. You guys are all great scientists. So where does this energy come from? Well, the battery, inside the battery, there's tons of chemical reactions happening. And these chemical reactions are providing the energy that's then pushing on those green electrons, those green dots that are representing the electrons, and causing them to flow through the circuit. So a really big idea here is the battery provides the energy that pushes on the electrons, getting them to flow, right? Causing the electricity to flow. And that energy is then transferred to heat and light in our simple circuit model here. Really cool. Nice job. Okay, so let's experiment a little. That's what science is all about, right? And experimental design, it sounds kind of intimidating, but really it's very simple. What you do is we want to study kind of the connection between two things. So I'm going to investigate this idea of the battery voltage, right? And I want to know more about the relationship between the battery voltage and the flow of charge, the current. So what I'm going to do is I'm going to change one thing, I'm going to measure another, and I'll keep everything else constant, okay? So I'm going to change the battery voltage. I'm going to observe the current by looking at that microscopic view, that flow of the green dots, and I'm going to make a conclusion. I'll keep everything else constant. So right now I'm gonna lower the resistance to 2 ohms. That's right, say it with me, 2 ohms. And I'll keep that constant. I'm putting it on an ideal setting, so we're gonna ignore all the energy lost to heat. And let me do some experimentation. Right now we're at 1.5 volts, okay? Now I'm gonna bump it up, 6 volts. I wonder what battery has 6 volts. You'll have to investigate that for me. 6 volts, ooh, what I observed, look at that flow of electrons. Definitely the current has increased. So right now, my conclusion is as I've increased the voltage, I've increased the current. Let's try one more time. Increase to 9 volts. A 9-volt battery is kind of like the ones you put in your smoke alarm. So here, 9 volts, I see that the current's really flowing through. So I'm going to make the conclusion that as we increase the voltage, we increase the current. And that's a really important conclusion. Okay, so good job out there. Let's do a virtual elbow bump. Whoop, whoop. Okay, I'm going to drop down the graphs and we're going to see if the numbers in the graphs support the conclusions that I made just with my eyes by looking at the microscopic view. Now, don't get scared when I drop down the graph. Graphs are your friends, I promise. They're so cool. We can really find out a lot by graphs, okay? They're just gonna illustrate the relationship between the variables that we've already observed in a more reliable way with actual numbers. So let's give a shout out to numbers. They are our friends, just as graphs are our friends. So let me drop it down. Okay, let's start over and repeat the experiment, but we'll look at the graphs and see if the numbers support our conclusion. Okay, 1.5 volts. So here's the voltage, 1.5 volts, and the current, just a little bit less than 1. And the current is measured in amps or amperes, okay? Now, I'm gonna increase that voltage to 6, just as I did before, and whoa, the current goes up to 3 amps. So the numbers back me up. It went from a little less than 1 to 3 amps. Now, one more time. 9 volts. 9 volts is about 4.5 amps. Let me zoom in. And you can see here that at 9 volts, if I go down, I'm about 4.5 amps. So the numbers back up my conclusion that as we increase the voltage in a simple circuit, we increase the current. I think that's a good start for today for our first lesson, but there's really just so much more you can do with this sim. So I'm gonna leave you now. All the links are below our live stream, but here's one idea. Why don't you set up a simple experiment investigating the relationship of the resistance on the current? Again, just adjust the resistance, observe what happens in that microscopic view to the current. Does it increase, decrease? And then another thing is, see if you can figure out where resistance shows up in the graph, because right now the axes just have current and voltage. I'll give you a hint. It starts with the letter S. Okay, so that's one experiment you can set up. Also, we have all sorts of things in the toolbar here. We have a tutorial video, which is another pre-recorded video on YouTube that walks you through kind of the higher level physics and physical science concepts. There's challenge me questions. And then if you scroll to the next screen, we have what we call slider-based questions. So if you click on the slider-based questions, it's going to bring you back to the sandbox, ask you to adjust the sliders a certain way to answer a question, and it'll give you feedback if you're right or wrong. So you can actually test if you're understanding the simulation and the concepts of voltage, resistance, and current. Okay, so I hope you'll try it. And then lastly, because at CK-12, we will never let you just stop learning. We are always trying to carve out different learning pathways for you. We have 4 more related real-world examples, and they all start with big questions because scientists just ask big questions. And here's one that I think is kind of fun. That looks just like my flashlight at home. Why do we use 2 batteries in a flashlight? Maybe you guys were sitting there wondering that when I pulled out the 2 batteries for my flashlight. So you can read this, and then I've posted a lot of supporting links from CK-12 for you to learn more about batteries and answers to some of these related real-world examples. Okay? So I'm going to stop sharing or actually I'll show you the cafe. So the link, one of the links below right now should lead you to what we call the CK-12 Cafe. And that's where we're going to come together at a cafe. And we are going to, here's the link to the sim and all the supporting links. And so you can explore, we even have a battery sim. So if you're wondering, and that led to some questions of like, how does the chemical reaction, the battery work to provide the energy? We have a simulation just on that. So I hope that you will start down your own learning pathways. And I will be here again tomorrow at the same time, same place, 11:30 a.m. Pacific time. And we are going to explore electricity and voltage further with the model of lightning. Because I heard when I said the word electricity, many of you shouted out lightning. So let's have some fun. Hopefully I sparked your curiosity, right? And we'll meet back tomorrow. We'll explore lightning and we will go travel down a learning pathway together, alone, but together. And I've had so much fun here with you today. So hop on CK-12, explore the flashlight sim, and I'll see you tomorrow. Bye-bye.